This is a system at Kellogg and Hillside here, a charity house that is still for sale if you'd like to buy it. It has radiant floor heat with water. There are 8 4x8 water collectors on the roof, and you can hear it circulating now. The water is pumped off the bottom. This is a fiberglass tank inside here. The water is pumped off the bottom up through this flow meter and sight glass into the bottom of the collectors. It goes through the collectors and out the high point and then flows back in here and into the tank, and you can hear it running now. This has been a very simple standard hot water system. This then takes the heat off this water and goes up and through and down here into radiant floor heating, and we'll show you that later. But right now, when this tank is all full of hot water, inside there is a stainless steel coil about 70 feet long, 60, 70 feet long, that the cold water coming into the water heater goes through there and goes through this coil and picks up the heat, and then it comes in to the water heater. And you notice this is closed off so it can't come straight down here. And if there would ever be any problem with that, we put this 3 valves on here that could always be shut off like that, and that would isolate the solar tank altogether and bring this right down into here as a normal thing to work on the solar tank or whatever you need to do. But normally these are all like this, and that's been a standard kind of practice that we've used that's been very helpful in any kind of repair work or whatever, that it totally isolates that tank and you can have just a straight tank. Up here is the fill valve. If you need to add water to that, every month or so you check the sight glass, and when the pump is off, this water will come down and you can see the level in here, and if it needs some water you can just add some water. Here is the controller, the Shem controller that is made by Solar Heat Exchange Manufacturing in Perry, Kansas. We hit this and it says T1, T2, T3. T1 is the temperature at the top of the collector, and it measures that. It's 111 degrees now, late in the afternoon. We hit this, T2, it shows the temperature at the bottom of the storage tank here, which is 105. And when those two temperatures get within 5 degrees, it will shut the system, the pump off, and then it will all drain back into the tank. T3 we have here is ambient temperature, just hanging in the air here. And what we do, this has 2 functions on this. One circulates it through the collectors, and the other one, when the tank temperature, storage temperature, is more than 10 or 20 degrees warmer than the ambient temperature, then it will turn on this space heat pump and run it through the floor. So with this one simple 2 output controller, we can have a whole system here that heats the hot water, that heats the house, and very simple. This is the whole controller and 2 pumps, and three switches does that. Now most hydronic systems are very complex with all kind of balancing valves and that, but this has been very, very simple, very efficient, and has worked very well. I've been real pleased with this. And of course then in summertime you can set the high limit to down to 100 degrees or whatever, so that you're not adding extra heat into the house, since this is inside the house. But in summertime you can put that clear up to 160, 180 degrees. So this is quite easy to control and does the whole system. This is the brains of the system. Okay. This house has radiant floor heat, which was designed to it. This is also an ICF house, which means insulated concrete foam. The kind of Lego type styrofoam blocks that are filled with concrete, which has been very efficient and certainly a very solid permanent construction. When there's enough heat in the tank, which we can set that anything above 85, 90 degrees, when there's that much heat, then it can pump it through here, and it comes through here, and we can adjust the 3 zones in here, and it comes back up through here. Now we don't have all the fancy balancing valves, we don't have all that, but in a simple house like this, this is certainly adequate. You want the heat in the house, and it doesn't have to make that big a difference exactly which room which heat is. So we have these all open, but we could just as easily shut off if we didn't want it in the northwest radiant northwest room. We could shut that off, or and run it through the other two or whatever. But that gives us significant control there without having to go through all these elaborate things. Out here then we have a line volt thermostat that is set at 70. We could set that up to 75, and so whenever there's heat in here, that will be putting it into the house. And in the wintertime, we turn this up high to 75 to 80, and in the summertime we turn this down to off, and the radiant floor heat will never come on. That pump will never come on, and so that just breaks the circuit. And so with this control and that CHEM controller, that is the whole control for heating our hot water and for heating our house. And this should very much keep the furnace from coming on almost at all, especially with good quality windows, with insulated concrete, with the roof attic well insulated. This should be a very highly efficient house. It could be your house. It's still for sale, and we'd like to sell it. It's for the proceeds go to the Mennonite Central Committee. So if you would be interested in a house, it's a beautiful house here at Kellogg and Hillside. Let us know and we'll get you in contact. Thanks.